Hello all. In this video session, we'll be discussing about the program to find the sum of complex numbers using struct. Okay, so you all know how complex numbers are represented. For example, we have 3 plus 5y where 3 is the real part and 5 is the imaginary part. Okay, consider we have two complex numbers c1 and c2 where c1 is equal to 3 plus 5y and c2 is equal to 4 plus 3i. Then sum equal to c1 plus c2 is equal to, so when we are adding two complex numbers, we will be adding the real part. After that, we will be adding the imaginary part. So adding the real part, we will get 7. Then plus adding the imaginary part, we will get 8. So we write 8i. So the sum is 7 plus 8. So this is the basic working of how addition of complex numbers. Now we will just write the program to implement that. So first of all, I'm just going to write hash include stdio.h. Okay, then after that I'm going to write struct complex for holding the complex numbers. Okay, and inside that we have a real part and an imaginary part. So I'm just going to declare two integer variables, int real and int imaginary. Okay, so this will be holding the real part and this will be holding the imaginary part. Okay, so now you can declare structure variables here. You can declare c1 comma c2 comma s, or you can just declare these variables inside the main. Okay, so I'm just going to declare this inside the main. So I'm just going to cut this. Then we have in the main. Since we are giving in the main, we should return some values, or return 0 if everything goes well. Then after that, I'm going to declare structure complex, then those variables c1, c2 and s. c1 for storing first complex number, c2 for storing second complex number, and then finally s for storing the sum of first and second complex number. Okay, so these is you have to remember. So it's a good practice to write the purpose of each variable. Okay, so first of all, I'm going to write printf, enter the real part of first complex number. Okay, so we'll be entering the real part of first complex number. So it is integer, so we are giving percentage d, and it will be read inside the real part of c1. Okay, so I'm going to give ampersand c1 dot real. Okay, now the same way we have to enter the imaginary part. So I'm just going to change this imaginary part. Okay, enter the imaginary part of first complex number. Then it is also an integer, and inside that ampersand c1 dot imaginary. Okay, c1 dot imaginary. So inside imaginary we have the value stored. Okay, then after that, okay, I'm just going to paste this. Then we have to enter the real part of second complex number, and we'll be storing that in c2. So here scanf percentage d ampersand c2 dot real. Okay, so it will be stored in the real part of c2. Then after that we have to enter or insert the imaginary part of second complex number. So here c2 dot imaginary. So scanf percentage d ampersand c2 dot imaginary means it will be stored inside the imaginary part of structure variable c2. Okay, how we can find some of these two complex numbers? So we have to add the real part and then we have to add the imaginary part. Okay, so s dot real is equal to c1 dot real plus c2 dot real, and s dot imaginary is equal to c1 dot c1 dot imaginary plus c2 dot imaginary. Okay, imaginary, and thus we'll be getting sum of the real part and sum of the imaginary part. Okay, and we can write printf sum is percentage d plus percentage di. Okay, and inside those we'll be, okay, not percentage, okay, we have to print I, so I have given percentage di. So inside that we should give the s dot real and s dot imaginary. Okay, so now after that, okay, we will be printing that. So I'm just going to give a new line so that the command line will be printed in the next line. Okay, so this is our program. Okay, so we have constructed a structure complex. Okay, and it has two members, real and imaginary. Then we have declared three variables for complex, c1, c2 and s. c1 for storing the first complex number, c2 for storing the second complex number, and s for storing the sum. Then we have read the real part and imaginary part of first complex number c1. Then we have read the real part and imaginary part of second complex number. Then here find out the sum of first and second complex number by adding real part and by adding imaginary part. Okay, so the sum of real part will be equal to the sum of c1 dot real and c2 dot real, and sum of imaginary part will be equal to c1 dot imaginary and c2 dot imaginary. Okay, sum of c1 dot imaginary and c2 dot imaginary. So we got those values, and then we have finally the printf statement for printing those variables. Okay, so here percentage d plus percentage di is given to print that in a format like a plus bi. Okay, now since we have completed the program, we will just compile this program and see that whether we have any errors. So gcc complex.c, then output it to complex.out. Okay, no errors. So I'm just going to run /complex.out. Okay, it is asking for the real part of first complex number. We're just going to give these numbers, so 3. Then imaginary part of first complex number 5. Okay, then real part of second, that is 4, and then imaginary part of second complex number, that is 3. Okay, so we will be finally getting sum as 3 plus 4, that is 7, and then 5 plus 3, that is 8. Okay, so sum of real part, that is 3 plus 4, that is 7, and sum of the real part, that is 5 plus 3, that is 8. Okay, so we will just try out one more example. Okay, just going to clear this, and I'm just going to, okay, I'm just going to do this. Okay, then I'm going to run this program again, and real part I'm just going to give 10, imaginary part let's say 5, then second complex number real part let's say 3, and second complex number imaginary part let it be 12. Okay, so sum is 10, the sum of real part of first complex number plus real part of second complex number, that is 10 plus 3, 13. Then the sum of imaginary part is sum of imaginary part of first complex number and imaginary part of second complex number, that is 5 plus 12, that is 17. So the answer is 13 plus 17i. Okay, so this is how you actually find, this is how we implement sum of two complex numbers using structures. Okay, the same thing can be done to find the difference, and also if we want we can find product of these numbers as well, but there are certain logics that we have to implement since we have to consider all the terms. Okay, so go through these programs. Okay, thank you.